Now next sentence, listen to me. Next sentence, next point I would say, if a force, there is a force which is directly applied to a string. If a force is in this direction, then tension is also in this direction. Okay. Say a man is pulling a string. Okay. There is a string, and a man is pulling a string, with some Newton. In that case, what will happen? Tension plus force of a man will be equal sum of. Okay. Here, a man is pulling a string from the other end with some force. Then tension will be equal to the given force regardless of the pulling agent, irrespective of whether the box moves or not, man moves or not. Now try to understand this sentence through diagram. This is our ground. Okay, there is a box and man is over here. Man is over here. Man is pulling. Man is pulling this box by using string. This is a string. Tension we know the tension will be over here. This will be our tension. Okay, over here. This is box. Let's just say mass is a something. 10 kg. Man is pulling this box whose mass is a 10 kg. What is happening? Tension and force is in this direction. So forces, direction of a force of a man is in this direction. So tension, direction of a tension will be also same. Means the direction of a tension is also in this direction, and direction of a force of this man is also same. It is same. T will be equal to F because T is directly proportional to F. Both are force. Whatever will be value. For example, over here tension is at 20 Newton and force is a 20. Both will be same. Whatever will be value of T will be equal to F. Okay, try to understand. Both are not different. Not at all. He just used a string, nothing else. So whatever will be applying, force this person will be pulling with some Newton will be also considered as a tension force. Okay, this was next point. Try to understand. Next. Don't think that this T will be something else and this F will be something else. No, direction over here is the same. That's why both will be equal. Whatever will be value of T will be also for F. Okay. Reason is direction is the same. Next is string is supposed to be massless unless stated. Hence tension in it remains the same. Tension will be same. If mass is massless, we know, everywhere and equal to the applied force. However, if the string has a mass, then tension at different points will be different. Being maximum will be equal to applied force at the end by which force is given, and minimum at the other end connected to body. Let's try to understand this through diagram so that we can get more clarity. Again, ground, not a ground but directly object with a string. So remember, if this object is not located, there is a no contact, there is a no contact, other no contact of other object with this object. In that case, over here our tens will be maximum. Okay, over here our tension will be maximum, and this starting this will be minimum tension over here will be minimum, and at the end will be tension will be maximum. This is what is mean. Let's say there is a object which is like this, and over here it is a contact with the roof. This string over here, it is with a roof. This is object 5 kg, 5 kg, 5 kg. What is happening over here? Here we can see, even we can get a feeling. Here, over here, at the end, this will, over here, our tension will be maximum. But starting points, at the starting points, tension force will be minimum. This is fact. Clear? But remember, condition is if diagram is like this, height, this is a height, or you can say it is coming in under gravity. Then we will see this in more details when questions will come. Now next one. Next point is, in order to produce tension. Okay, let's say we are producing this by using string. In a string, to equal and opposite stretching force. This is a string, and we want to produce tension force just by using this. So two equal and opposite stretching force must be applied. Then tension thus produced is equal in magnitude. Magnitude will be same to either applied force. T will be equal to F. We are pulling this object. We know if a direction is the same, then this F will be equal to T. If you want to produce tension force, of course we will apply our hand so that we can stitch the object by using string. Then whatever force will be applied by us, then will be equal to tension force. This was my point. It is explaining. This is box. Okay, this is box. We know tension will be in this direction over here. So force is opposite, direction is opposite, but amount is the same. Direction is opposite. So what is happening over here? String, we have a string, and just we are pulling the string. Okay, like this. What will happen? Length will increase. Yeah. What will happen? Length will increase. Amount of force is the same, but direction is the same, and result will be what? length will increase. Length will increase when external force will be applied. Okay, next we have next point. Every string can manage a maximum tension. Every string maximum tension means limited force. When person will cross the force to stretch a string, then string will be broken. So every string can manage the maximum tension. If the tension in a string is continuously increased, tension force is increasing inside the string, then maximum tension by the string can be managed. It will break beyond a certain limit. What will happen? It will break beyond a certain limit. Some certain limit. Try to understand. Again and again I am repeating this sentence. Here beyond means ahead of a limited force. Whatever will be maximum tension force by the string, that string will vanish. But string has a limited what limited tension. If a tension is crossed, then that string will break. That's the self. Okay, this is enough. Certain limit. Next sentence: the maximum tension which a spring can bear without breaking is called. Let's say whatever will be maximum tension by the string. Then what is happening over here? We are stretching. Let's say we are stretching a strength. We are stretching a string, and we reached at a certain amount of a force. Now the string is not broken. It means we can consider this phenomenon, maximum tension, as a breaking strength. We stretched, and at maximum tension we can consider this as a breaking strength. Okay, this type of a strength will be breaking strength. Breaking strength means ahead of this breaking strength, whatever amount of force will be applied, then result would be this string will be broken. Okay, whatever amount of force will be applied beyond breaking strength. Okay, then string will be broken. Now let's change the topic. Next topic is weight. There is a huge difference between weight and mass. Mass is just amount of matter. Remember, what is the difference between weight and mass? Mass is just amount of matter, amount of molecules of matter of a body. Here, weight is not amount of something. This is a force. Weight is a force. Okay. Whatever you want to know, you want to know. Let's say you want to know weight of a bottle, which is a filled of water. Okay. Then of course you will put a bottle like this. Then it will come into gravity. We will get weight as a result when object will be perpendicular to earth, perpendicular to earth, then we will get a weight of mass. Just understand, weight over here is, it is a mass. Okay, mass, weight is a force, mass is not force. You can say applied at the center of gravity vertically downwards. So whatever will be applied force on object. So applied, this is the applied force at a center of gravity. Again I am telling you, this is just total object will be perpendicular to center of the earth. Okay, so applied at the center of gravity vertically perpendicular downwards, then we will get weight force. So yeah, weight force can be written as mc, because of this is a downward force. That's why weight force is just a downward force. Okay, yeah, so weight force will be equal to mc. Okay, now over here, this is an example for weight force. Over here, weight force for this will be mg, for this also mg. Clear? Weight force for this also mg. Now let's take a little bit different example from this given example. So next, this is a ball and object is like this. It is in rest. Okay, this is in rest. In that case, we can say weight force will be like this, mc downward. Remember, mc is always downward. Weight force is always downward, not horizontal. Okay, not horizontal, not at any angle. Angle will be straight downward. Angle will be straight downward. Okay. For this mc will be like this, downward. For every object, for each object, mc will be downward. Clear? Clear? One more figure, which is inclined theta. Again, object came over here. Now let's see how much forces are being applied on this object by the other objects, whether it is a gravity or a muscular force. Let's see. First we can say this weight force, which is downward like this. This will be downward, mc. Yeah, isn't it? Yeah. We can break this mc in components x, y. You would say this will be our straight. So angle is, if angle is this, so this side will be mc cos theta. Just we are breaking the components of a given resultant force. So resultant force is mc. So one component of mc will be mc cos theta according to theta. So next will be our mc sin theta. Clear? mc sin theta. Remember, this side will be mc sin theta and this will be mc cos theta. Here only mc is our resultant. If you add mc sin theta plus mc cos theta, you will get mc. Clear? Now, this is one force, this is another force. In this direction, mc is a downward, exact downward. Now, what about normal force? So this upward will be our normal, but right now we are not explaining normal force. We have a separate part for normal. Okay, just understand over here. Just we broke this mg into two components. So two components are over here, mg cos theta, mg sin theta. Mm, yeah. So over here you understood how the how mg can be broken. You have understood. Now let's take a question based on this concept. A block is placed. Make the FBD diagram of a block. This is a table. This is table. On this table there is a block. On this table there is a block, and mass is m1. Mass of this table is m2. Both are different in the term of mass. Question is saying a block is placed. This block is placed. This block, it is talking about this object. This object is placed on the table, and the table is kept on earth. Yeah, this table is kept on earth. Assuming no other body in the universe exerts any force on this system, make the FBD of a block. This FBD of this M1. A1. One thing you are crystal clear. There is a mg. Yeah. Another will be N upward force, N just perpendicular to object. Okay. What else? What else? So if FBD of M1 will be nothing but mg. This normal force will be equal to mg force. Why? Reason is downward force minus upward force will be equal to 0. When normal force will come in this side, this will become mg will become n2. Same thing we wrote over here. You understood that this thing came from over here. Downward minus upward. Okay, downward minus upward. Free body diagram of M1 will be N1 it will be equal to MC. Okay. Free body diagram of M2, this M2. We are talking about now table, okay, about a table. So for this MC, again MC, and upward in. here we can see this object is applying, force on table. Yeah, what is happening? Can you say m2 for table will be m2 will be equal to n1. N1 is what? This will be mz plus this mz2. Okay, mz2, mz2, or you can write mz plus mz2, or you can write mz plus mz2. This is your choice. Okay, so it can be written as m1 z plus m2 z. Just we put the value of n1 from over here, n1. So whatever was the force, of m1 object which was applying downward on the table, we will add with this force. N2 will be equal to n1 plus n02. This n1 is of a force of m1 object which is applying force downward. Over here g is a constant. Yeah, g is a constant. m1 plus m2 means whatever will be value of z, we know 10 meter per second raised to power 2. So 10 will be also for this object and 10 will be also for table. Okay, value of the z for both will not be different, but masses are different. Okay, masses are different. That is how we will find the free body diagram of any object when it comes to 2 or 3 objects. Next, next is contact force. Contact force is also normal force. Let's read this statement about normal, about contact force. This is also a reaction force which will generate on applying an external force towards a perpendicular to contact surface. Means this contact of this body is with a table, so contact is compulsory. In this contact force, we can say upward is our normal reaction force. Okay, upward is normal reaction force. Thus, following two types of a contact force will generate. Two types of force we can see. First will be flow diagram. We will try to understand. First over here, if this is the surface of the body, and force is acting like this, in that case, normal reaction or contact force will be upward. If body is like this and acting force is in this direction, this is a acting force, then just opposite of this acting force will be our normal reaction or contact force. Normal reaction. which is coming from Newton's third law. Okay, third law. So normal reaction will be just opposite of acting force on the object. And next we have remember reaction force is equal to contact force. If a force is like this at angle, in this case we saw that force was downward or vertically or horizontally, but in the other case it is making an angle with horizontal. If this is happening, acting force is like this. In that case, we will break the components. We will bring the components of this given acting force. Okay, acting force. So this is our result. So normal force will be upward, and acting force is in this F R. This is our resultant force. So upward force will be normal force, and this is a resultant force. So remember R will be equal to N square plus F square, because we are considering this force as a resultant. So remember this will be equal to, and here angle is 90. So Pythagoras can be used over here. So R will be equal to under root of M square plus F square. Reason is angle is, we used Pythagoras theorem because of angle is 90 degree. Okay, angle is 90 degree. If we do like that, then a resultant will be equal to under root of the sum of these two forces. Okay, two forces. And tan theta. If you want to know angle between this vector resultant and another vector, then you have a formula tan alpha. Tan theta will be equal to this upon this, P upon B. So N upon A half. Okay, N upon A half. Then you will get a angle, this angle, which is between a resultant vector and a component vector. Clear? Okay. Now let's move. Next is the normal reaction. In first sentence is for normal reaction. When an external force applied perpendicular towards contact force like this. So applied force is downward, okay, perpendicular towards the contact surface. This is our acting force, okay, external force, surface. Then this reaction force will generate. The normal reaction will be upward. So reaction of this if acting, which is a perpendicular to contact surface of the body, then our reaction of this force will be normal reaction. reaction of this A part will be normal reaction. Okay, normal reaction. Action, reaction of different objects. Of different. So remember, this is a normal reaction of the earth. Okay, this is a normal reaction of the earth, and here force which is acting on the this is a small box, not on earth. Clear? And this normal reaction is of earth. Clear? Clear? This force is of pushing nature. Pushing nature means it is talking about normal reaction. It is pushing the object. This let's say object name is A. In this normal reaction, it is a force which is pushing the A object. That's why we consider it as a pushing force. Pushing force. So remember, this is a pushing force. Tension was a pulling force. Here this is surface is pushing what what the body. You would say body A. Okay, body. Next we have this will represent perpendicular to contact surface passing through the body on which it is applied. Diagram is like this. There are two boxes which are together. Okay. Applied forces and are in this direction. Applied force. We have to observe normal reaction. When object will hit the, let's say this is A and this is B. When a object will hit the B object, then what will happen? What will happen? This B object will give a reaction which will be A. Okay, A. This B will push the A object. A object. This is what will happen. This is what will happen. Now, if object is both are like this on the surface, what is happening over here? Upward force, upward object is pulling the downward object. Okay, A object is pushing the B object. So this pushing will be our normal, and it is also pushing this object, which will be also normal. Okay, these two objects are pushing the earth, and earth is pushing these two objects normal. Clear? Okay, question is based on normal reaction. Based on normal reaction. Based on normal reaction. Object is in a rest. Object is in a rest. acting force is like this. Normal reaction we have to find. Normal reaction. This is figure as a question. It is object. This is what. This object is in rest. Acting force is in this direction with the some rotation. Some rotation. I try to understand. Question is in the flowing diagram. If a block is in equilibrium, then found out the normal reaction on block and value of F. Value of F. This value and the normal reaction. Clear? Normal reaction. Can you bring the components of this F? Yeah, we can. So angle is according to this theta, this will be our F cos theta, and perpendicular, this will be F sin theta. Yeah, we can write. We can write. There is a no problem. There is a no problem. So F sin theta is upward. F sin theta is upward. Okay, downward is a mz. Downward is a mz. Okay. Okay. In this direction we have F cos theta, and in this direction what will be normal. Normal. In this direction will be our normal. From this figure, you can directly write like that. F sin theta will be equal to mg. Reason is downward force minus upward force. Mg minus F sin theta will give us F sin theta will equal to mg. This is what we will get. Similar with the F cos theta and n will happen. This F cos theta can be written as, this will be equal to n. F cos theta will be equal to n. The result is very simple. I have told you. Final force minus initial force will be equal to 0. Acceleration is a 0 with a constant velocity. Velocity is a constant. Question was asking normal force. So normal force is nothing but F cos theta. Question was asking also F. So F will be our, over here F will be our mg upon sin theta or cos theta. F will be also n upon sin theta, n upon cos theta. Okay? So finally we have brought value of F and value of n. So for n we have F cos theta, for F we have mg upon sin theta. Clear? Clear? Try to understand. We have a value of F. We have a value of F. Just put. So value of F can be written as mg upon sin theta multiple cos theta. The another value of n will be mg tan theta. Not mg tan theta but cos theta. Mg cot theta. So can you write this n equal to mg upon tan theta? Yes, it can be written. Clear? This will be your another value of n. This was an initial value of n. That is how you will bring. Now let's take a real example, real question, real question. We have seen how to bring a normal force, how to bring a aim force, how to bring a cos theta, tan theta, sin theta, all this. Now let's bring all these things by the equation. By the equation. By the equation, yaar. Find out normal reaction N1 and N2. N1 and N2. Where figure is like this. There is a hole. Object is inside it. Angle between the wall is a 60 degree. This is surface 1 and surface 2. Surface 2. Question is asking normal reaction 1 and N2. N1 and N2. N1 and N2. Can you say this will be our MC? Yeah, you can see. You can see. From this contact force, this will be our what? Normal. Let's say this is an N2. Yeah. From this contact force, we will have N1. You know. How we brought this N1 and N2? From this contact. This is wall is pushing this object. This surface is pushing this circle. That is how we brought N1 and N2. Ng will be always downward. Okay. You can draw this figure over here. Like this. There are three vectors. How much? 3 vectors. Tell me, brother. Tell me. If you stretch this line, okay, this line, what will happen? What will happen? Try to understand. If you bring this like this and over here, what do you think? What is going to be angle for this N1? We will say this will be our 60. This will be our 60. Reason is okay. If it is 60, can we say this will be also 60? Yeah. N1 cos theta, N2 sin theta, same with this, N2 cos theta and N2 sin theta. N2 sin theta. First is N1 sin 60 will be nothing but mz. This N1 sin theta is equal to mz. Okay, you can say mz. So N1 will be equal to mz upon sin 60. Value of sin 60 is going to be root 3 upon 2. Root 3 upon 2. But it is in denominator. This sin theta is in denominator. So our 2 upon root 3 mz. This will be our N1. N1. Okay. N1. So for N2, we know this N2 cos theta is equal to N1 cos theta. N1 cos theta, which is a 60 degree. So value N2 can be written as, this N2 can be written as 2 mz upon root 3. Just we put a value of N1 and then cos 60 will become 1 by 2. Finally we got mz upon root 3. This is value of the N2. mz upon root 3 is the value of N2. Clear? Yes, this is clear. Next. Figure is something like this. Center of this circle will be over here. Downward will be our mz, and this contact will provide N1 and this contact will provide N2. Clear? N1 and N2. Vertically opposite angles. This N2, N1 downward. Vertically opposite angles. This will be equal to 90. Yeah. Angle between N1 and N2 is 90 because both are perpendicular to each other. This is 90. This is 90. If it is 90, then this will be also 90. Okay. Okay. Try to understand. Question is asking N1 and N2. N1 will be sine 30 over here. Try to understand. N1, this is N1. N1. In front of N1 is what kind of angle? This angle. In front of N1 is this angle. In front of Lemis theorem. We are just observing Lemis theorem. So N1 upon will be sine 30. Sine 30. Question is saying over here 120 degrees equal to 60 degrees. So angle is given by the question. Angle is given by the question. So this angle is making 60 degrees and this angle is making 30 degrees. Over here it is 90. Remember. So this one force, this second force, this third force, mg, gravitational force. You can write n1 upon sine 60, n2 upon sine 30, this mg upon sine 90. Okay. So this will be equal to n2 upon sine 60. Sine n2. Where is the n2? N2. This is the sine 30 here. N2 is in this direction. So N2 upon sine 60. So N1 upon sine 30. It is correct. So N2 upon sine. This is N1. So N1 is in front of 60. Is equal to mg upon sine 90. Here we can say n1 upon sine 30 is equal to mg upon sine 30. We took this so that we can find the value of n1. We can find the value of n1. Okay. Sine 90. From over here, n1 can be written as mg multiple sine 30 upon sine 90. This can be written as. So after simplifying, you will get how much mg multiple 1 upon 2 multiple 1, which will be equal to mg upon 2. Yeah, am I correct? mg upon 2 or mg, yeah, mg upon 2. This is our answer. Remember, it is value of n1. Now let's find n2. You can write n2 will be equal to mg upon sine 90. mg upon sine 90. n2 will be equal to mg multiple sine 60 upon sine 90. mg multiple sine 60 will be root 3 upon 2. Sine 90 will be 1. You can say mg root 3 upon 2. This will be our n2. It is a value of n2. Okay. So finally we brought our answer. If a figure is something like this, try to understand. This one, okay. This is one, this is another. Let's say it is n1, n2, and third is a mg. Angles are same. 120, 120, 120. If angles are same, then you can say forces will be also same. Forces will be also same. Okay. The reason is angles are same. Okay, angles are same. That's why all the values of forces will be same. Remember this point.